Assalamualaikum, my name is Natasha binti Kamal, matric number S68468. Today we are from Group 5. I would like to present about exploring the nutritional quality of plankton for phytoplankton as chlorella and zooplankton as artemia. So this is our teammates. Next, introduction to plankton. The term plankton is derived from the Greek word for drifter or wanderer. An organism is called planktonic if it is transported by tides and currents and is unable to swim against them. Plankton float over the duration of their life cycle, while others are only categorized as such in their early stages before finally be able to swim against the currents. Plankton typically becomes microscopic, measuring less than 1 inch in length, although it also includes larger species like crustaceans and jellyfish. Plankton can be classified in a variety of ways, including size and drifting phase duration. The most fundamental classification divides plankton into two groups, which is phytoplankton, plant-like, and zooplankton, animal-like. So this is types of phytoplankton. For the first one is phytoplankton. Phytoplankton are microscopic plants that play a significant role in the marine food web. Phytoplankton like chlorella is a distinct type of freshwater microalgae that has a smell similar to grass and only one cell. It has the largest chlorophyll content of any known plant, which gives it its distinctive emerald green color and pleasant grassy smell. So next, zooplankton. Zooplankton are planktonic animal components. Plankton are a variety of aquatic organisms that are carried in the direction of the current, rivers, lakes, seas, and other bodies of water because they are unable to swim against the water currents. So this is the overview of ecological role of plankton for marine and freshwater environment. Plankton are at the bottom of the food chain, which means they are essential for marine and freshwater food webs. Phytoplankton are also primary producers, which means they employ photosynthesis to convert CO2 to oxygen and account for up to half of the oxygen we breathe. They are a main food source for zooplankton, which is ultimately eaten by larger species including fish and other organisms. So for the first one is phytoplankton. Phytoplankton are primary producers. So in the ocean, they go through from ocean and then to biological pump, carbon cycle, economic phytoplankton application as food supplement and animal feed, and then to environmental factor effect by phytoplankton. So next, zooplankton. Zooplankton has a crucial role in connecting planktonic primary producer with big carnivores, including explosion prawn fish species. So this is the diagram for zooplankton from which may focus on grazing. Grazing by phytoplankton is a rate setting processes in the aquatic ecosystem that also drive aquatic biochemical cycle. So aside from linking primary producers to higher trophic level in the marine ecosystem, zooplankton play a vital role in nutrient recycling, influencing biochemical cycle and biological pump.
Hi, my name is Muhammad Hafiz Luqman. My metric number is S68385. So I'm here to present about nutritional composition for artemia and chlorella. Let's start this presentation by talking about the nutritional composition of these two. First, as we can see in the table above, artemia and chlorella provide high quality protein that were crucial for growth and health of fish. For the lipid, artemia is superior in providing essential fatty acids like EPA, DHA, which are directly beneficial for many fish species, while chlorella offer ALA that are beneficial but less immediately utilizable compared to EPA and DHA. So next, artemia offer a moderate carbohydrate that are useful for energy, meanwhile chlorella provide carbohydrate and high fiber content for aiding in digestion, especially for herbivore and omnivore fish. Lastly, for the vitamin and mineral, artemia is rich in vitamin A, D, E, and B complex that are supporting overall health and metabolic process. Meanwhile, chlorella just offer a broader range of vitamins including C, K, and B12, and also rich in minerals that supporting immune function and vitality for fish.
Okay, my name is Nino Aina Medina Ibrahim. My metric number is S68440, and I'll be explaining about how does the nutritional composition varies among different types of plankton. The nutritional composition of phytoplankton and zooplankton vary widely among different types, primarily due to the first one is because of the species. Different species of phytoplankton and zooplankton have distinct biochemical compositions. The second one is diverse feeding habits. The third one is physiological and ecological characteristics. Next is cellular structure and metabolic activities. And lastly is because of environmental conditions. including light, temperature, predation, pressure, and nutrient availability.
Hello, my name is Muhammad Arif bin Zulkifli and my metric number is 68407. Okay, I will talk about the importance of plankton in aquatic ecosystem. Firstly, we will talk about the significance of chlorella as the base of the aquatic food chain. Firstly, the chlorella is the energy that transferred to various aquatic organisms, starting with small herbivores like zooplankton, which are easily consumed by the bigger predator. Then, chlorella also contribute to oxygen production and carbon sequestration, supporting our ecosystem health and biodiversity. Its high nutritional value make it essential food source for many aquatic species. Okay. The role and the impact of the chlorella in aquatic ecosystem. Firstly, as the nutrition for aquatic animals, chlorella can serve as nutritious and balanced diet and promote the growth and health of the aquatic animal. Second, immune and disease resistance. It boosts the immune responses and enhance disease resistance in these animals. Water quality improvement. Chlorella absorbs the excess nutrient and reduce harmful compounds. The impact of chlorella is with optimal light pollution, it promotes the growth and reproduction of chlorella. Nutrient level. Nutrient essential for chlorella growth, but with high concentration, it leads to algae bloom. With temperature, it affects the metabolic rate and growth. Okay, the third one is the significance of Artemia at the base of aquatic food chain. Firstly, Artemia serves as an essential food source for the larvae of many fish and crustaceans due to its high nutrition and ease to cultivate. The second one is the Artemia role in the food web support the growth and survival of these larvae. We are crucial for maintaining healthy fish population and biodiversity. The role and the impact of Artemia in aquatic ecosystem. Firstly, as the growth, it being the nutritional source. Artemia have a rich protein and other nutrients and make it the excellent dietary component for culture species like fish, larvae. And that is the growth development, even accepted and tolerated by aquatic organisms. Aquaculture practice. It is crucial in diet of aquaculture species and lead to efficient, sustainable production practice. And for impact, salinity. The variation salinity level can significantly impact their population. Temperature. The Artemia can tolerate in wide temperature range. Food availability. As feeder, Artemia depend on availability and microalgae nutrients. And also the last one is the water quality. Thank you.
Assalamualaikum, hi, I am Ayana Soha, S66899. So today I'm going to talk about application in human nutrition and food security. Okay, the first thing is potential plankton as a food sources. Okay, for you guys to know, potential plankton as food sources for human are really high now because we can see a lot of become product from the plankton, such as we have a biscuit for spirulina and also cracker for Artemia. Okay, for your information, with the more efficient than the transplant, phytoplankton have the potential to become a new resource of offering the high protein substance of the soya-based supplement and meat. This we can see the phytoplankton have really high in the protein that can become one of food for the human, such as a supplement. Okay, in human food sources, phytoplankton are really well known. As one example is spirulina, which is typically used to biscuits. If you want to know, they already sell it around the market now, so you can find a lot of biscuit from the spirulina. And we're going to talk about the zooplankton. Now the food content of zooplankton is really well known because a lot of things, a lot of recipe they become the Artemia and from Artemia. Yes, you can see like kebab and only. Okay. For the healthy benefit of taking plankton product, like I told earlier, it content is high on protein, so it can give energy that at the bodily growth. So it's really good for the kids that want to grow up. And for your information also, it offer the dietary and phytochemical components that are benefit for cancer, eczema, and diabetes. And it's really good to this kind of the thing. And for your information, it also content is vitamin K, which is for you, if you guys don't know, vitamin K is helping to block clot or clotting coated and it's going to coat it properly. So if you have a problem with the bulk, you can take vitamin K that have in the Plankton product. Innovative to add fruit challenge. Okay, fruit challenge are one of the things that we know that the more you feed with food safety challenge, you are a good food to give the human. So the innovation that have in the both of the product for the Cruella, the new product that can be developed include the protein powder, vitamin, and muscular biscuit. So the protein product that have in the market now also can contain with the Cruella that can give the more protein. Like vitamin, like I said earlier, we have the vitamin K that's good for the clotting blood, and biscuits is really well known now in around of the market, and it's more cheaper than the spirulina. For the Actimia, now it's more used in the regular meats like curry, omelet, and kebabs. You can find a lot of the recipe to Actimia product. And for your information, now is in UMT also we have the snack who are content is Actimia, like the cracker that's help a lot of human to taste and get a more protein.
My name is Nazima Fatima Ali. My metric number is 67990. Okay, today I will present about the challenges for culturally Chlorella vulgaris and Artemia, and also about researcher effort and to overcome the challenges. The challenges for culturally Chlorella vulgaris, especially in harvesting, firstly high energy and operational costs. This is because it has to hire many labor for harvesting, and it also high energy because we need a lot of labor for harvest the Chlorella vulgaris. And next, efficient harvesting technique. Developing efficient method for harvesting Chlorella vulgaris is crucial. Various techniques such as centrifugation, sedimentation, flocculation, filtration, flotation, and their combination has been employed, but it has its limitation and optimum condition. Okay, for processing challenge, contamination issue. Chemical used in flocculation or bioflocculation can contaminate the harvested biomass, which can be significant issue in the production of high value product. For downstream processing, the harvesting step is critical for the downstream process, as it leads to a highly concentrated solid matter that requires further processing. And for consumer challenges, digestibility, especially for larvae fish, they have problem with their digestive because they not well development of their digest. And for allergic reaction, some of individuals may have allergic reaction to Chlorella vulgaris, necessitating throughout testing and clear labeling. Okay, the challenges for culture Artemia, especially in harvesting, firstly high production costs, especially high labor costs. This is because in traditional harvesting techniques such as manual collection using net harvesting can be labor intensive and time consuming. And for seasonal variation, Artemia population is in natural saltwater habitat experience seasonal fluctuation, impacting their availability for harvesting. For environmental sensitivity, Artemia population are sensitive to environmental factors like salinity, temperature, and water quality. For processing challenging, debris removal. After harvesting, Artemia must be separated from debris and other impurities. This process can be labor intensive and may require specialist equipment to ensure the purity of the final product. For preservation, maintaining the nutritional quality and availability of Artemia during processing and storage is crucial. Preservation methods like freezing or freeze drying are often employed, but this can be expensive and energy intensive. For nutrient retention, processing method may result in nutrient loss, affecting the overall nutritional value of Artemia for harvest and for larvae fish. For consumption challenging, for digestibility, while Artemia are commonly used as feed for larvae fish due to small size and high nutritional content, this digestibility can carry dependence on factors like larva species and development stage. For uniformity, active uniform size and nutritional composition of Artemia batch can be challenging. For health risk, poorly processed or contaminated Artemia can pose health risk to larvae fish, including exposed to pathogen or toxin. Okay, for research effort aim to overcome the challenge, especially in Chlorella vulgaris. Firstly, the research will use electron coagulation flocculation. This method uses electrochemical reaction to coagulate and flocculate macroalgae, reduce the need for chemical and improving efficiency. It has been shown to be effective in harvesting Clara vulgaris and other species. For biofilm growth, growing microalgae as biofilm on substrate can simplify harvesting and processing by allowing for easy separation of the biomass from the culture medium. Growth C. vulgaris or as biofilm on textile fabric or other substrate to improve growth rate and simplify harvesting processing. For natural flocculant, using natural substrate like chitosan and calcium hydroxide can be an environmentally friendly and cost-effective approach to flocculate macroalgae, reducing the need for chemical additive. Besides, utilize natural flocculant derived from the microalgae itself or other plant-based biopolymers to facilitate harvesting, reduce cost and environmental impact. For optimal growth condition, ensure sufficient light level for photosynthesis as inadequate light can lead to decreased growth rate and lower productivity. Maintaining optimal temperature for growth, as fluctuation can affect the stability of the microbiomes. Provide the necessary nutrients such as nitrogen and phosphate for optimum growth. For researchers' effort aim to overcome the challenges for culture academia. Firstly, environmental management, that's like optimum water condition, regular monitoring and adjustment of water salinity, temperature and quality can help maintain optimal condition for Artemia growth. It also can be used to control the environment such as indoor tanks or greenhouse can also help mitigate the effect of environmental variability and protect the culture from contaminants. For improved seed quality, optimum condition for apply hatching to ensure high quality seeds according to standard Artemia hatching protocol. Besides, classify and fingerprint Artemia seeds based on size, hatching performance, growth rate, nutritional value, and other characteristics to ensure the right product for specific application. For proper storage, storing dried Artemia seeds and biomass in airtight container in cool, dry condition can help maintain their quality and hatchability over time. And last, nutrient enhanced techniques such as gut loading and bioencapsulation are being explored to enhance the nutrition of Artemia for larvae fish, ensuring optimum growth and development.
So next, I will be presenting about the recommendation of future research direction. So first, we should utilize live feed for human nutrition. Regarding this topic, there are minimum to none research done on how to apply plankton as human food. This is because they have a small size and is regarded as wasteful if it's used in human food. Despite their small size, zooplankton such as Artemia can potentially serve as alternative ingredient for the production of biscuit and protein powder due to their high level of protein. So secondly, the research direction that we should be aware of is the culture system. The current culture system of plankton has a high risk of crashing. It is inconsistent and has a low efficiency. One main reason is that plankton does not tolerate well to a change in water condition. They could not survive and adapt to the poor water quality. Hence, we should research a better system such as a automated water changer or a better monitoring system so that we can maintain the water parameter to fit the plankton needs. So next, we should research about a higher quality of feed for the plankton. Feed for plankton is not researched well. The most commonly used feed is microalgae, yeast, and rice bran. Not all the species of the microalgae can be cultured. Some microalgae that has potential to be feed for zooplankton could not be used in aquaculture at all. On the other hand, yeast and rice bran, they have a high nutritional value, but they are unsuitable to be used as feed for plankton due to they can deteriorate the water quality quickly. So lastly, we should research on the toxin of phytoplankton to be used as human medicine. Some phytoplankton such as cyanobacteria can produce toxin. This toxin can be used as treatment for human disease. As an example, they found that toxin of cyanobacteria can used to slow down the growth of cancer cell in human.
In conclusion, phytoplankton and zooplankton together create a balanced and productive environment in aquaculture. Phytoplankton provide the primary source of energy and help maintain water quality, while zooplankton serve as essential food for fish and help control disease. By supporting the growth, health, and sustainability of aquatic animals, both phytoplankton and zooplankton are vital to the success of modern aquaculture practices.